Hello all. This is a little demo of the PyMetaBolex software. Um, so to start out, what you're going to want to do as a prerequisite, you ought to have a NIH BioWolf account. If not, I can't really help much with that. But assuming that you do, you're going to want to type git clone and then copy this URL here, as I've done at the top of your screen here. Um, and then press enter. They'll ask for your, of course, you're also going to want to be added to the GitHub. At the moment it's private, but feel free to email me. I'll provide my email at the end. So you just type in your username and then your key. I explained in my GitHub how to set this up. So it's pretty standard. So then you've copied metabolics, apologies. And then sorry, let me navigate to, you want to mount your HPC drive, go to YouTube demo, PyMetaBolex, and then so then you're going to have these things. So this is the README, this is the logo. This is the output from the real data. I'm not supposed to put the actual real data from our metabolomics project of the cohort of malnourished children. So what this input data is um, it is uh, the raw data. So it's the same. I can actually just show it to you guys. Um, it's the same like subject diagnosis, except these values, they're like based off the mean and like standard deviation. So like they're like the around the same values, but each one is like randomized. So like this patient didn't have a value of 16.6, but like it gives you an idea, but you're not really gonna be able to like steal the data, if that makes sense. So that's why I randomized it. So to go back, we have this data. So let's say you have your data. You want to make sure you have subject diagnosis here, right? And then name it whatever the phenotype you want to call it, and then whatever, however many various metabolites here, and then the values. Okay. So the first thing you're going to want to do is go navigate yourself to the source folder, and then the generate data or the config.txt. So this is going to ask you your input file. You can make it whatever you want. Probably you want to put in an input. So if you have QC files, which I do, then you're going to want to put yes and specify. And then RSD threshold is different for liquid versus gas. Liquid, I think, is 20, gas is 30. But again, you can set that. Uh, then other metabolomic software encourages that you do various filterings. You can look this more up. But the default values are pretty generic. You can normalize, and then I don't, I choose not to perform normality tests. On my data, like too many of the metabolites are removed, but you have the option to where if it doesn't like pass the Shapiro-Wilks test, it'll remove. So you have that. So then what you're going to want to do is you're going to want to navigate to PyMetaBolex. Um, and then you're going to want to make sure you're in even though I'm already in it, then you're going to want to do source or Python 3 source/generate data. And then it'll take about like 800 rows, doesn't take very long. So then it creates a data folder with um your data that you want. And then it has a little log, which is nice. It lets you know how what was filtered out at each step. Overall, about you started with 892 and finished with 605. So that seems to me like a reasonable um amount of data to be left with. So then we're gonna navigate our way back to our source folder. Then we're gonna go to group config. So it's possible most of these tests are run best if you like only look at two groups, and it's possible that your data set will have many groups. So what you're going to want to do is put in odds are it'll generate as final data.csv, and then name the group. In our case, there's three phenotypes, but they belong to two groups. So name this, then like the two subject diagnoses here, and then group two this and this, and basically it'll make a new one where it replaces like each one with one of the two group names, which is probably better for most of our tests. And then group Python 3 source/group, and then run that. It'll tell you. It also generates a ranked data matrix, if you're interested in that. Um, and then it's there. And then finally, and you can do this multiple times. You can run it and then change the group names again and run it, run any real combination. Then finally, we actually get what we want. Or I guess you could theoretically just want to, it's pretty helpful for, making the data better. And I think it's pretty interactive and intuitive. And finally, we're gonna want to do a source, go to here, and then to the run jobs dot, uh, no, the run job info.txt. Gonna open that. And so basically you write the name of the program. Here are the 5 programs that are currently offered. And you can open them to like see a more thorough description of what they do. Then second, you want to write the actual like the data file, like the data you want to access. And then third, you want to write where you want it to output. So for this one, you want to run the cluster.py on this data file, and you want to output it to output/cluster. And so, yeah, you can add more. I can just add, let's see. Let's say I want to evaluate data.py of data slash, that is slash, nope, that is quite frustrating. Uh, and non uh, ranked, that's CSV, then output slash it capital evaluate data ranked, and then oh yeah, and then so then we can just add that. So now 6 jobs will happen, and then let me just make sure that the data it ends in ranked, right? Yep, so that should work. So then we just go here, Python 3 source/run jobs.py. So then in my estimation, it takes about not too long, maybe like 30 seconds on a data set of running all tests on a data set with 30 patients and 700 metabolites. So you can kind of calculate on your own how it might scale, but it's not one of those things that takes super long. And then all jobs completed, it'll generally let you know if anything's wrong. And then, so this is this output data. So we have 2 things. We have output malnutrition, which is like the real output data, which is helpful, like from real data. So that's on the GitHub. You can view all the charts and stuff from that. And then you just have normal output. And then you can see, let's just look at this. So then it shows a number of plots that are useful. The cluster test I find particularly helpful. Um, like it shows it explains here, but these the dots are phenotypes, the mesh background are like decision boundaries for k-means clustering. There's random forest and linear regulation will be more helpful if you have more samples than I do. I only have about 30. You want about 10 samples per feature, so you probably want like 1,000 samples ideally, because it's all about like training and testing data. But overall, and then like you can see, like output ranked is different. So the large thing is if you want the malnutrition data, if you want the real input data instead of this fake thing on my GitHub, you can request and I can ask for permission to give it to you. I'm sure I can. My email is right here, dmasachi@stanford.edu. I would very much appreciate anyone who wants to use it, and I'd be happy to like kind of work one-on-one with anybody if they're confused. Uh, I think overall it gives this software gives a lot of helpful ways to visualize the data. It's pretty easy. As you can see, it's once you set up your source files, you just run 3 commands and it takes about a minute to generate. Yeah, that's about it. I might be coming out with more updates as things progress. Feel free to email me any ideas, updates, concerns, criticisms, anything. Yeah, that's it. Thank you all, and have a great day. Thank you.